No. Manganese 4 oxide, because that 2 is a reduced form out here because it was Mn something O with a 2 minus crisscrossed, right? And that 2 and then is right inside. So that means the outside number had been a 4 if we reduced it down to 1 and 2. So that's just a catalyst, and again, you just put whatever the catalyst is or the condition on top of the arrow. It's just a condition notation as well. Precipitate, downward arrow, or PPT. By putting PPT on the end, that means it's a precipitate. Or you could just put solid. All those things mean the same thing. A precipitate is a solid form. So they all can be equally denoting the same thing. You can see in this example I've got, I can read the symbols without reading the written out part. So solid iron reacts with solid sulfur to make iron 3 sulfide, right? And so you can see it in the formula here. How is, you notice that this is not balanced, right? Law of conservation of matter says that atoms are not going to disappear, matter does not disappear. You just simply rearrange them and put them in new combinations. So this is a new combination. I've taken an element plus another element to make a ionic compound. How many irons are present on the product side? How many? There are 2 irons present. Do you see the subscript of 2? It's pointing out there are 2 irons. So how do I balance that? I can only add coefficients when I'm balancing. Okay, do not add subscripts when you're balancing, or superscripts, or crazy scripts, okay? Coefficients. So where do I put the 2 over here? Okay, there's a big number in front of iron. And then what do you notice sulfur? How many sulfurs do I have? 3. So I'm going to put a coefficient of 3. Ta-da, it's balanced. That's it. So after we write out the equation, that's when we go backtrack and balance it out. So let's just do maybe 2 or 3 of these, and then you guys can finish them out. Okay, so I'm going to read. You tell me what to write. When solid zinc is added, ZnS, to a solution of copper 2 sulfate, Cu, SO4, and then how do you indicate solution of? A little AQ right on the outside, okay? So when solid zinc is added to a solution of copper 2 sulfate, aqueous zinc sulfate and precipitate of copper are formed. So seeing those are formed, so I'm going to go ahead and write the yield 0. And aqueous zinc sulfate, go. ZnSO4, where are the 2's at? They reduce, right, as does the copper 2 sulfate one. And that's a solution of, so you put AQ and Cu for copper. And then you put a down arrow or PPT or S. All those mean the same thing. Okay, so let's go ahead and balance this one. How many zincs are on the left, on the reactant side? 1. You see 1 zinc. How many zincs in the product? 1. Great, so far. Okay, how many coppers on the reactants? 1. How many coppers on the products? 1. Sulfurs? 1 sulfur. Sulfurs? 1. Oxygens? 4. Oxygens? 4. Boom. What is the ratio for all of these? 1 to 1 to 1 to 1, right? So I'm not even going to write the ones, but we know the coefficients do exist there. Okay, easy peasy. Not too hard. Okay. When solid, magnesium chlorate. Magnesium chlorate. Get me started. Mg. Good. We know chlorate is ClO. Hold on, ClO what? 3. Parentheses 2. Good, because magnesium's got a 2 plus charge. Don't forget that. So when solid is heated, so what else do I need here? And a little s. And then what do I write now? Yeah, the yield symbol. And with the yield symbol, it says it's heated, so that heated notation is triangle, okay? Then it says solid magnesium chloride and gaseous oxygen is formed. So it's solid magnesium chloride. Mg, Cl, and that 2 is coming from magnesium's charge. Am I going too fast? Is this okay? Are we okay? Okay. And that's a solid, so you put a little S on the outside. And oxygen, or gaseous oxygen, that is O2. Okay, a big mistake is that whenever we're writing our single elements, normally we just write a single element. You know, copper, Cu. Except for those diatomic molecules. You must write the 2 as a diatomic. So oxygen has to be a 2 here, not just an O. O2. So that's gaseous oxygen, and you put a little G on the outside. Okay, let's balance this one. How many magnesiums in the reactants? 1. There is an imaginary 1 right here, so we are saying there's 1 magnesium. Magnesiums on products? 1. How many chlorines on reactants? 2. Yeah, that 2 is That 2 is distributed inside. So there are 2 chlorines. How many over here? 2. We're good. Oxygens? 6. So 2 times 3 is 6 oxygens. So what do I need to add here? A 3 coefficient, right. Don't forget, you're only adding coefficients once you've written out the full-out products or reactants and products. Okay. And this one, I want you guys to tell me, of our 5 types of reactions, and you'll see these reactions in Reading Guide 11. The 5 types are synthesis. Think about what that means. What does synthesis mean? Huh? What did you say? Just take a guess. Making stuff. You take 2 things, you make something. Like photosynthesis makes glucose from the sun and other jobs, right? Chemosynthesis means to make stuff. Synthesis just means to make. What does decomposition mean? To break down. Which do you think this one is indicating? Number 2. You can see that magnesium chloride is being broken up, breaking down. So you can actually start to recognize these. This is a decomposition. Okay. Let's do, from you, those of you who've already started, which one do you have a question on? 5. I'm hearing anything else? Start with 5. Okay. 5. When electricity is applied. Okay, so this is a condition, and if a condition is present, you just note it on top of the arrow, yield symbol. So electricity is applied, so I'll just go ahead and write lightning bolt, or electricity, or whatever you want to write there, okay? Electricity. Okay. To liquid water. So what's my reactant? H2O L, right, liquid. You cannot have aqueous water. Okay? Water dissolved in water. Is that a mixture? No, it's a pure substance. You cannot have aqueous. You do not put AQ on the outside of water. You put L. It's decomposed into hydrogen gas and oxygen gas. So what are my 2 products? H2, good, because you know your diatomics, gas, and O2, gas. Okay, so that's it, and you already can tell this is a decomposition because it says the word decomposed, but it also, you can see it breaking down. Balances, how many hydrogens? 2, 2 are good. Oxygens? 1 and 2. So what do I need to do? Say again? So I have to put a 2 in front of water, right? And that 2 actually applies to everything past it. When the coefficient there is applying to everything past it. So that means I got 2 O's. Great, but now what do I have? Right, you can see I have 4 H's here, so I have to put a 2 in front of this H. And then I'm good. Okay? I'll do 4, yeah. Yeah, thank you guys, should be. Thank you, Dory. Okay, solutions of, so these are aqueous solutions, of silver nitrate. What is silver nitrate? Ag, good, NO3. Where are the charges? What are the charges, sorry? What's silver's charge? Do you remember my stupid way? Yes, do you remember it? Can you do it with me? It's number 1. I was really hoping just thought you'd do that with me. It's number 1, okay. And then nitrate's a 1 too, 1 as well. So there's silver nitrate, AQ, plus sodium bromide. And that's those charges are what as well? 1s, right? Those are 1 and 1, and that's aqueous as well. Okay. React to form aqueous sodium nitrate. So aqueous sodium nitrate. Go ahead. NaNO. Nitrate is nitrate, right? You told me what nitrate was right here. It's the same guy. It's just rearranged. So its partners are changing. NaNO3 here as well. And there's AQ out here. Their subscripts are 1 and 1 again. Okay. And then silver bromide. Good. That's Ag with the 1 plus, bromine with the 1 minus, crisscross 1 and 1. Are there any subscripts here? Are there any subscripts? This is a trick question. What are the subscripts on everything? 1. There are subscripts, guys. They're all 1s. So if everybody's got a 1, sorry, I'm going to actually why don't you think of this differently? I just said they all are 1, but you're looking at it, you're like, no, that O has a 3 right there. If you think about these sometimes when their partners are just being switched, do you notice that silver and sodium just switch places? Took them over here. That's called a double replacement reaction. 2 things are switching, right? Double replacement. That nitrate is still nitrate, and that nitrate is still nitrate. So sometimes I'll just, instead of calling them N and O separately, I'm just going to say, how many nitrates are there? How many nitrates are there? What's on the outside? One. There's one nitrate there, and there's one nitrate there, and sometimes that helps you balance it quicker versus going to ends and O's and separately. And then you need to precipitate this. All right, that's there. Okay. So how about you guys finish those up? You guys got 10 more minutes. You can probably finish that.